the boiling points of the alkanes, they are increases with the molecular masses and decreases especially when there is a branching in the carbon chain. Chlorine free radical. We know that we have used a 2-chlorine molecule which absorbs the sunlight and forms a chlorine free radical. What are isomers? We know that isomers are the organic compounds which are having same molecular formula but different structural formula. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Hydrocarbons. Under that, we have learnt about what are hydrocarbons and also we have dealt with the classifications of the hydrocarbon, and finally we have learned that what are the methods of preparations of alkanes. Is it right? Today, let us move on to the next part of this unit. We are going to learn more about the physical and chemical properties of the alkane. So, when you say it is a physical properties of the alkane, it is very simple. We all know that alkanes will having the alkane members, when you write, it will be started from n is equal to 1 and it will be extended up to n is equal to 10 as we know from the members. Is it right? The lower members of the alkanes are generally they behave like a gases, whereas the higher members of the alkane are generally they are solid. In between these two members, some members will act like a intermediates and they are become liquid at a room temperature. This is the first important physical state of the alkanes. So, what are those? The lower members will be exits in a gaseous state or in the gases, whereas the middle one, ma'am, how do you say it is the middle? That is from the carbon 5 to carbon 17. This is from carbon 1 to carbon 4 I can say. This is after carbon 17, what all the molecules are there, they are known as higher member and they are become solid, whereas the middle one, they act like a liquid at room temperature. This is the first thing you need to understand, that lower members are always behave like a gases, whereas higher members, they behave like a solid, and between these, some members will exit from carbon 5 to carbon 17, they behave like a liquids. And coming into the solubility, this already we have learned that alkanes are paraffins. They are not soluble in water, but they are soluble in organic solvents such as benzene, ether, etc. When it comes to the boiling point, the boiling points of these alkanes are also increases with increasing in a molecular mass. If number of carbon atom is increased in a chain, their boiling point is also get increased. If branching is there in your carbon chain, then the boiling point will be started decreasing. This is another important thing that we need to understand while studying the physical properties of the alkanes. So, what is the second property? The second property tells us that the alkanes are insoluble in water but soluble in organic solvent. And remember, the boiling points of the alkanes, they are increases with the molecular masses and decreases especially when there is a branching in the carbon chain. Next is chemical properties of the alkane. In that, first I will go for the halogenation. Do you know what is halogenation? The process of addition of halogen to the carbon atom, it is known as halogenation. In that, so halogenations will be taking place at very higher temperature at 573 to 773 Kelvin or in presence of diffused sunlight or in the ultraviolet light. For that, I have taken out the methane, which is allowed to react with a halogen called as chlorine. That is, we have number of halogens. Is it right? Chloro, bromo, iodo, fluoro, nitro. Is it right? So first I'll go for the halogen atom. So I have considered the methane which is allowed to react with the halogen in presence of sunlight. What will happen? One of the hydrogen is removed out and it will be substituted with the chlorine and forms a chloromethane, and there are two Cl will be there. One H combines with another Cl and forms a HCl. When this chloromethane, again if you react with the chlorine in presence of sunlight, one of the hydrogen will be removed and forms a dichloromethane. When this dichloromethane again treated with the halogen in presence of sunlight, one of the hydrogen will be removed to form a trichloromethane. Okay, or you can say that it is a chloroform also. Okay, next, if you take this trichloromethane and to react with the halogen in presence of sunlight, it forms what? Tetrachloromethane, and HCl will be formed. This is how we can easily prepare the alkane by doing halogenation. We can understand this reaction by taking the steps which is involved in this mechanism. The first mechanism of this step is the chain initiation. How does the chain will be get initiated? Let us see now. The chlorine molecule absorbs the energy from the sunlight and gives rise to the chlorine free radical. We know that we have used the two chlorine molecule which absorbs the sunlight and forms a chlorine free radical. This is a chain initiation step. The second step is chain propagation. So what does it mean? The chain will be get propagated, which will be get increased by adding the number of carbon atom. So the chlorine free radical reacts with the methane to give a methane free radical and HCl. So one of the radical reacts with the methane in presence of the sunlight and forms a methane free radical and by forming a HCl. This is a chain propagation step. This methyl free radical attacks with the chlorine atom to form a methyl chloride and chlorine free radicals which is also get formed. So this methane free radical, this is my radical, allowed to react with a one more chlorine molecule in presence of sunlight. What does it do? So this methane combines with the chlorine and forms a chloromethane and one chlorine free radicals which is also get created here. In the last step, that is in the chain termination step, what will happen? These free radicals are combined to form a product. Chlorine free radicals to combine to form a chlorine molecule. Similarly, methane free radical combines to form a methane molecule, whereas methane free radicals and a chlorine free radicals combines to form a chloromethane. This is how we can easily understand the mechanism of chlorination of methane. And remember, this mechanism of chlorination of the methane, it is very important for the examination point of view and it will be asked for 3 marks. Okay. Next is another important reactions, that is combustion. We all know that we are very much familiar with hydrocarbons. They can easily burnt in the air. Is it right? And produces what? Carbon dioxide and water molecule. Let us see with the example of combustion now. So alkane, upon heating with excess of air or with the oxygen, it gets completely oxidized to form a carbon dioxide and water with the evolution of heat. So we know that if you burn the wood, it produces what? Carbon dioxide and it produces a large amount of heat. Is it right? Yes. So you can see that this is my alkane which is allowed to react with excess of oxygen. It forms what? Carbon dioxide along with the water molecules. Since during these reactions it releases the excess of heat where my alkane which is completely get converted into carbon dioxide where it is undergo complete combustion, and this reaction is also named as complete combustion. Named as complete combustion. Okay. And there is a one more combustion known as incomplete combustion. What does it mean? Let's see now. The combustion of alkane will be carried out with a limited supply of the air and results in the formation of unburned carbon particle, which is used in the preparation of ink, printers, etc. You can see that I have taken out the methane which has been heated with the limited quantities of the air which undergo incomplete combustion to form a carbon and a water molecule. This carbon which is not completely get combusted, hence it is known as a carbon black, and this will be used in the printers, especially it is used as a ink. Okay, this kind of reactions are known as incomplete combustion, where my alkane is not undergoing complete combustion. It's not undergoing at all. It is an incomplete one. Next is controlled combustion or controlled oxidation. Here, so the alkane upon heating with regular supply of oxygen at a very high pressure and in presence of a catalyst, by using a different catalyst, we can give rise to the different product also, and this type of reactions are known as controlled combustion, which is known as what? Controlled combustion. Here you can see that methane, when it is react with oxygen, where you are supplying only the required quantity of oxygen to burn or to combust this methane. Okay, in presence of copper as a catalyst, it forms what? Methanol. Similarly, if I use the methane in presence of oxygen by using a catalyst called MnO2 and O3, it gives us to the methanol, that is an aldehyde. Similarly, if we use the ethane, when it is react with the oxygen molecule in presence of manganese CH3COO twice, it gives us to the ethanoic acid. You can see that there is an acid which is produced, aldehyde which is produced, and there is an alcohol which is produced. When you do the combustion by controlling the entire reaction by supported the limited quantities of the oxygen which is required for the reaction and by using the suitable catalyst for the reaction, you can see that different kinds of the product which is also get obtained. The ordinary alkane resists the oxidation, but the alkenes which are having the tertiary hydrogen atom which is get oxidized and to give a respective alcohols, especially the methyl propane in presence of manganese, it gives us to the 2-methyl propane 2-ol. This is how if you use a different catalyst, you will get a different product while doing the controlled oxidation or controlled combustion, we can say. Next is isomerism. What does it mean? Let's see now. An alkane upon heating with presence of anhydrous aluminium chloride and hydrogen chloride gas get isomerized to give a branched chain alkane. Here I have considered the long chain hydrocarbon. So it is an N-hexane which is allowed to react with anhydrous aluminium chloride. What will form? It will form a isomers. What are isomers? We know that isomers are the organic compounds which are having same molecular formula but different structural formula. You can see here these carbon atoms are one and the same in the 2-methyl pentane and 2-methyl pentane. Is it right? But the structural formula will be different. How is it so? You can see that it is a 2-methyl pentane and this is a 3-methyl pentane. Because here you can see that this is my substrate group which is attached to the second carbon atom. But here you can see that the substrate group which is attached to the third carbon atom. Is it right? Hence, even though this is an isomer which is having the same molecular formula, but the structural formula will be different. So, this process of obtaining an isomer which is known as isomerism, this will be done in presence of anhydrous aluminium chloride. So, hope you all understood with this example. Again, I am explaining. I have taken out the N-hexane. This is a alkane which is react with anhydrous aluminium chloride. It forms what? Isomers of N-hexane, that is 2-methyl pentane and 3-methyl pentane. How does it comes? That is mainly because you know that the substituent group CH3 which attacks to the second carbon atom. But in this isomer you can see that it is attached to the third carbon atom. So if the organic compound having the same molecular formula, if the structures are different, then we say it as isomers. Okay. And the last reaction is aromatization. What does it mean? We know that N-alkane having more than 6 carbon atom upon heating with 600 Kelvin at 10 to 20 atmospheric pressure in presence of oxidizing agents known as vanadium, chromium or molybdenum supported over the aluminium to give aromatic hydrocarbon. This process which is also known as reforming. So here you can see that I have considered the CH3, CH2, 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 CH2 and CH3. There are 6 carbon atoms will be there. Remember, this is not a cyclic carbon chain which is allowed to react with vanadium pentoxide or chromium oxide or with the molybdenum oxide which is supported with the aluminium at a very high temperature and a pressure around 10 to 20 atmospheric pressure. This undergo reformation and results in a formation of benzene ring. This process of obtaining the benzene ring from the aliphatic carbon chain which is said to be aromatization. The process of obtaining the aromatic carbon chain by aliphatic carbon chain, it is said to be aromatization. So, hope you all understood with this method. Again, this is very important for the 2 marks. Have a look on this and try to note down. And next is reaction with the steam. How does our alkane reacts with the steam now? Let's see. When a methane reacts with the steam at 1000 degrees Celsius in presence of nickel as a catalyst, carbon monoxide and hydrogen will be formed. Here I have considered the methane. It reacts with the steam which consists of water droplet in presence of nickel as a catalyst. This methane will be get reduced to carbon monoxide with the release of hydrogen gas. This process which indicates that hydrocarbon can also be reacted with the steam and forming a carbon monoxide which is a poisonous gas. And next is pyrolysis. What does it mean? The process of decomposition of organic compound on heating, it is known as pyrolysis. So the process of thermal decomposition of alkanes into the smaller molecules are also known as cracking. So decomposition of any hydrocarbon which gives rise to the simple molecule. Is it right? Here I have considered the propane. There are 3 molecules of the carbon atom, hence it is a propane, which is upon decomposition which gives rise to the propene, as well as ethene will be formed, and with the release of methane molecule. Here I have one more example of C6H14, which is nothing but a hexane, which is upon decomposition by heating, it forms a hexane along with the hydrogen, and similarly it forms a ethene with the ethane, and it also forms a ethyne with the ethene along with the methane. So both the alkene and alkynes are obtained due to the decomposition by heating, which is also known as pyrolysis. So in the next class, we are going to understand with the conformations of alkane. So by this, I like to say that whenever we are discussing with the alkene, alkene and alkyne, please note down their members, then write the physical property, write their chemical property and write the method of preparation. This is one of my suggestion to understand organic chemistry very easier way, and if you write down only, you will come to know that what are all the reactions which is involved in a particular types of reaction. So hope you all understood in my class. We'll meet you in the next session. Till then, take care, be safe.